Yeah, we'll start in a minute. Yeah, good evening, everyone. So, if two of you join, we'll wait for 2 more minutes and we'll get started. Yeah, good evening. Yes, hmm, yeah. So, we'll have a formal introduction once I'm just waiting 1 minute for others to join, if anyone taken this course. Can you mute yourself? Who is unmuted? Yeah, good evening, everyone. So, today we'll be formally starting our online sessions on environmental quality monitoring and analysis. First, I will introduce myself. My name is Anup. I am a research scholar from Department of Chemical Engineering, IIT Madras, working on electrochemistry under the guidance of Professor Ramanathan. So here, I think four of you joined for this course. Can you people introduce yourself so that I can know who all are coming from which uh, area like that? So can you? I'll call one by one. So Chandra Mohan, yeah. Hmm. Okay, which institute? Okay. Hmm. Hmm. Okay, both from NPTEL. Hmm. Hmm. Which one? Hmm. Yeah, this week actually we will be explaining week one portion. I will slightly explaining week one portions and discussing the assignments. Like that, we will be going next week content plus assignments. Like that, the way we'll be following. So, like that, if anything, you can note down my email ID. So you can write to that. If any doubts or clarification, I am in direct contact with the faculty also. If I am not been able to clear that, I can discuss with him and clear the doubt. My email ID is I'm writing here ch20 d021 at the rate smail dot iitm dot ac ac, ac dot in. Hmm. So I'll write it clearly. That's so that others who are joins late also can easily read. Hmm. ch20 d021 at the rate smail dot iitm dot ac dot in. Hmm. Next person, Sagar. Hmm. 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 Of course. Okay. You are working, right? So you finish your MTech masters and started working. Okay. Good. Good. Hmm. Okay. Hmm. Hmm. Okay. Thank you. Next person, Ebin. Hmm. Hmm. NIT candidate. Okay. Oh, you are PhD scholar or master scholar? PhD scholar. NIT candidate. Okay. Then next person, Surat Devan. Hmm. Yeah. Fine. Hmm. Uh, yeah. Which one? What? My email ID. Can you see the screen that environmental quality monitoring and analysis week one? I have written there, yeah. Yeah, actually, I am working on electrochemistry. So this is a part of PMRF. You may be knowing Prime Minister Research Fellowship Scheme. So we have to help you people for better understanding. So all the questions, maybe I may not be able to answer at the right moment, but I will get back to you. You can anyway communicate to me this through this mail ID. So if some questions I cannot answer at that time, I'll be either replying or in the next class I'll be discussing that one first. That will be the way I'm planning to work on. Then Professor Ravi Krishna is taking this course. He is head of department in chemical engineering IIT Madras. So difficult question I can directly connect to him and get it solved. That's not an issue. Yeah. Hmm. Then next speaker Ankit. Hello. Your voice is very low. Yeah, no problem. We can barely hear you. So meanwhile, all of you got chance to go through week one videos. Week one is like overall a overview of what we are going to see through this whole series of lectures. So we have one assignment that have you submitted assignments? Assignment one. Then what about this? There was a quiz, non-graded quiz also, 5 questions. Were you able to answer it? In NPTEL, I think there is a quiz also, like 5 questions, non-graded. Is it there? Okay. Any of others, have you seen that portion? No, fine. Maybe it's maybe for last year it was conducted. It's fine. Follow up the site. It will be like it's not a formal NPTEL. I'm not connected to formal NPTEL course. I'm assigned to take the clear doubts and discuss the assignment questions and all after it's solved. That's my official part. So shall we get started with the course a little? What I'm planning is initially I'll just slightly discuss what sir have taught for first week of lectures. Then we will be seeing the question answers from 1 to 18. 18 questions are there in assignment one. We will be solving those questions and seeing the answers. Fine. I'll get started. Uh, Okay, assignment two. What is the deadline for submission? Okay, okay. In that scenario, I have to. It's actually grading one, right? Yeah, yeah. In that case, I have to discuss it because before the deadline, if I am discussing the answers and all, I have to ask with the faculty also because it's grading one also. Hmm. Okay, okay. Now I will get in touch with the faculty once. Then I will ask about it. Then next week, this week I cannot do anyway because I am not sure about this thing. So next week, surely, if it is possible, I'll be get in touch. If you are writing mail to me, I'll be discussing those topics as per the faculty's advice, like whether it's possible or not. Ask Sagar. Hmm. Yeah, I will be. I won't be going all through because there are 6 videos. I think 6 videos are there. Almost 3 hour lecture is there. So I'll be slightly going through the overview what sir has taught. It's just a introduction classes. So you'll be understanding what all things we are going to learn in this entire time of this course. So we'll slowly start the content. The course name is Environmental Quality Monitoring and Analysis. It's running from January to April window. So first point, uh, the name itself, course name itself is Environmental Quality Monitoring and Analysis. So first thing we all want to know is what is environment. So we can have slight discussions as well. So you can also what you say refresh what you have learned. So any of you can answer what do you mean by an environment or what how we can define environment. Yeah. Hmm. Yeah. So we can say anything that is in common with humans, in contact with humans, we can define it as environment. So, like this is a very simple definition of environment. So, whatever which is in contact with our human body, we can define it as environment. So, when we are coming to environment, as I shown in figure, we can divide it into uh, when we are coming to environment pollution, we can divide it into 3 parts. It's called pathway. First one is source. Second one is environment. Third one is receptor. That is, from a source, the pollutant get emitted. It will transfer or transport through the environment and reach the receptor. Receptor is commonly human beings. So this is the common way. Here we have the emission from source. We have emission from emission to we have a environment, and through environment it will transport, and it will reach that human. It's called exposure. This is the general pathway of pollutant. This part we can also say fate and transport. So when we come to this one, first part emission, and source pollutant is emitting. So how can we differ or classify this? How different ways? I think you all have gone through the video. Can one of you unmute and tell how can we classify this emission? Hello. Yes. How can we classify this emission? Yeah. Can you be more? Hmm. Yeah, we will go one by one. Like, what is the emission chances? So, I will explain it. We can say one is emission can happen through various processes. It can be a combustion process. It can be a combustion process. It can be a manufacturing process, like different industries, chloralkali industries. Everywhere we have what you say, fossil fuels. So suppose coal is burning, so CO2 is getting emitted, carbon monoxide, incomplete combustion, NOx, extra getting emitted. So it can be a process, and it can be most known. We have petrol and diesel engine based vehicles, so there is continuous emission from those kind of transportation station sources. Then another way of classification is we can classify them using the sectors. In sectors, how what are the different sectors we can which can give up to emission of pollutants? In any of you? Yeah, it can be industries. Then what else can be? What? Yeah, it kind of an industry, right? So another one is it can be domestic agriculture. Yeah, vehicles can be. I'm due to lack of space, I'm writing straight. Vehicles, etc. Then, first, this can be a broad classification of emission sources. So, next one is after the pollutant gets emitted from the source, it will transport through. Sometimes what happens, like you all know Bhopal gas tragedy, what happened? Got leaked at some point. People got affected up to a long distance, right? So, next portion is the environment is the transport medium for these pollutants to transfer. So what can be the transportation? Here we write transport. What can be the medium? One, uh, air, water, uh, then soil, mm, animals. How animals, plants? Yeah, it's actually air. We already given an example. Water we know. Suppose we are taking a what is a textile industry. What happening? So they are using dyes and everything. So I'm taking an example. So after that, water they have to. Hello, can you mute one, Sagar? Yeah, thank you. So water after treating, they will be discarding the water. Water will be reaching some water resources like river or something. Then it will get transferred slowly. Maybe some animals, maybe aquatic life, all are affected by this pollutants in water. So through that, it will transfer and it will reach humans. How humans can get affected by this? There are what are the ways human? take these pollutants into their body? What are the ways? Inhalation. Yeah, it can be dermal, that is skin. Then it can be injection, that is oral. Injection, that is we can say it's oral. While speaking itself, it can happen. So this is a general classification from source to receptor. We'll elaborate our environment a little more. So we have defined what are the, we are taking four parts, like one is water, one is major source of pollution, then air, then we have soil, we have sediments. So water, we can define either it can be fresh water, second source is saline water. Then what is the other the definition or classifications are given in the class? Ground water and surface water. So can you anyone give example of surface water? River can be lakes. Yeah, good. Then next part is air. What all air contains? Yeah, may major portion is nitrogen. Almost 78 percentage of air is nitrogen. So whatever we are having here, there is wind and everything. Whatever we have in the air, it's always getting transported like one place to another. So that's why it's called molecular diffusion. I'm not going too much deep into chemical engineering. So when if you are or keeping a acetone bottle opened or something, some perfume open at a one corner of a room, slowly with time, what happens? It will reach the other corner of the room. So like that, we have diffusion process which can take air or gases at one corner to another corner. Then we have major constituent oxygen. One second. Yeah, thank you. Then we have argon, such gases. Then what we have? Then we have in air particular matter. Then we normally have other vapors and gas like that. Then next part is soil. Soil mainly contains minerals. Minerals, we can divide it into three parts. One is sand, then next one is silt, then third one is clay. So like that, it's going. Then part is sediments. Sediments means we have a water body. Here we have air. Here we have water. Then bottom we will have settle. It's called sediment. Sediments. It will be the bottom part will be filled with water body. Then what happens is the main problem with the sediments is slowly whatever chemicals discussing, some chemicals will get deposited at the bottom and it will remain there, like aquatic life and all are affected by this one. So these are the classification of environment. So what we can see, these bodies are not independent. There can be transport, mass transport from, suppose we have water here. Water is always in contact with air. Then it is water and air is in contact with soil. Similarly, sediments are there at the bottom of water. So from here to here, pollutants can get transferred. Similarly, air to water, this transport is possible. Then soil to water, etc., etc. These transports are possible, and of course, plants and animals are there. From these all things, they can get affected. Then there are pollutants which reach humans through secondary transportation media. Then another important part is how we will understand whether a chemical is having uh, exposure limit is. So we will always hear like the up to. I will take an example. I am working on carbon dioxide reduction. So people always says there is adverse effect on environment by the carbon dioxide. So increasing carbon dioxide in atmosphere is causing climate change. Similarly, there are some other chemicals. So what is the problem? How we will understand? For this, we have a plot called, what is this plot called? To understand if there are any chemical, is it in the safe limit or is it in the uh, danger position? What we call is dose response analysis. What we will do? So, how many of you are from chemical engineering background? So, have you everyone? Okay, good. So, how many of you know about tracer experiments? Have you learned about this residence time distribution? Chemical engineering, yes. Yeah, chemical reaction engineering. What we will do in experiments? So in a reactor, it's not a reaction, it's just a tracer experiment we will do. We'll inject a certain amount of tracer, then we will see how it's coming out with time, the chemicals. So for different reactors, we have different residence time distribution. Like that, how the chemical is coming out will be measuring. So similarly, we have a dose response curve here. Dose is what the chemical we are injecting, then it similarly have a response. So sometimes it can be a linear, sometimes it will go like this, like there will be a threshold. After that, it's causing a problem. Then it can be non-linear also. It can be go like this. So initially, uh, what happens is as dosage increasing, the response is in the sense of health effects. Um, so don't worry, video I am recording. So I'll be delivering this, uploading this video and sharing the link. So don't worry about it. The video will be receiving. So that is dose response. So such a dose response thing is called LD 50 percentage. What is that LD 50 percentage? Yeah, it is called lethal dose 50. Suppose this limit is this, like if it is exposed, 50% of the people supposed to die due to that dosage. That is called mm, lethal dose 50. So these kind of studies are called. We'll be coming in the coming weeks. We'll be coming back to this kind of terms and all. So this kind of studies are called toxicology studies. What is toxicology? Toxicology studies. So I think this is the portion which we covered in video one, right? Hello. This is the portion covered in video one, right? I think introduction, like that 45 minutes video. Have you how is the videos coming to you through NPTEL? Is it like 6 videos delivered this week, or how is it weekly? How many videos are shared in the week one? 3. Okay. What are the introduction? I think up to this portion, it's introduction, right? So anyway, I don't know. I have the videos with me, like with access. So in this first video is up to this. Then we will move forward. I think up to this, you got an overall idea what's happening. Like from source, a pollutant is getting emitted. It is getting transported through different media, that is air, water, etc. Then finally it is reaching human being. There is a interface. It is called what do you say? It is called exposure interface. Then from source to environment, we have a emission interface. Then there are whatever coming to air. There is also chances like carbon dioxide is getting dissolved in oceans and all. It is increasing the acidity. It is getting affected the aquatic life like that. It's all are interrelated. So in order to understand how much lethal it is, we have a dose response curves. What amount of chemical or pollutant in atmosphere can affect how much. Those kind of toxicology studies we have dose response analysis. So we'll go forward. So next portion is chemicals of concern. So we will classify the chemicals in different way. One of the classification is organic and inorganic. So how can we define this? What are the categories coming in organic? I think most of you may be not liking organic chemistry like me. So organic chemicals, carbon is the backbone. Yeah, it's any organic chemical. The backbone is made by carbon chain. So suppose we have CH3, CH3. This is a commonly used chemical. Like all of you maybe heard use always methane. These all are organic chemicals. So it contains, it's a hydrocarbon too. It contains carbon backbone. So how can we classify organic chemicals? What are the major two categories? Aliphatic. Second one is aromatic. So in aliphatic, we have already learned a lot, right? Like what are the things in that? We have alkanes, we have alkenes, then alkynes. What are they? This is saturated one. These are unsaturated hydrocarbons. So here we have only single bond. Here we have double bond. Here we have triple bond. So CH4 is an example of alkane. C2H4 is an example of alkene. Then C2H2 is an example of alkyne. So like that, we have this one. In addition to that aliphatic, we have aliphatic derivatives also. Sorry, we have derivatives as well. Derivatives. Suppose we have instead of CH4, we will substitute one hydrogen with CH3Cl. This is a chlorinated compound. This another aliphatic derivatives of aliphatic hydrocarbons. Then second one is aromatic. When we are saying about aromatic, first what will be the first structure coming to mind? It's always benzene will come to our mind. So another example is benzene have only single ring. So if you have two rings, it is called naphthalene. We have similarly three ring structure. It's too much organic chemistry. I am not also deeply knowing about these things. This is called phenanthrene. So naphthalene and all during my MTech time and all, one of my lab mate was studying the problems of naphthalene in drinking water, domestic water, etc. So in ppm level itself, it causes huge problem. There are standards. You may be already aware about it. There are different standards for each chemical. Beyond this limit, it is considered to be what to say chemicals of concern. It's not permitted. Suppose we have a industry which is throwing water into a river, there should be a certain standard. So these all chemicals should be below the maximum allowed limit so that they can discard it to the common water bodies. So now we come to some other categories are we can say polyaromatic biphenyls is an example of aromatic. Then we have substituted aromatic compounds like benzene. We can have chlorobenzene, etc. These are all aromatic compounds. So when we come to inorganic compounds, what are the main things? What we commonly see? Yeah, mainly so we have salts, ions, etc. Then heavy metals. Previously, I don't know whether any, how many of you went through the Pollution Control Board website. I think they will be giving different numbers like this should be less than this many ppm, this milligram per liter. Yeah, when you go down, you can see lead, etc., lead, tin, etc. These all should be below the level. Mainly, some of you are working in industry, so you may be knowing the standard procedures and all for discarding. So another classification of chemicals, we can divide it according to their application. Any of you tell what are the different? So one can be pesticides. Then I worked in textile industry, so I know how much uh, for quality control measures we have to take while discarding anything to outside sources. We have to treat it. We will be having a effluent treatment, wastewater treatment plant. We have to take so many things like BOD, COD, etc. before discarding it to the color, order, everything. We have to test before discarding into a water body or anywhere. Into any land, we anything going out from the plant, it should be tested and it should satisfy the pollution control standards. So we can have textile industries, textiles. Another one is fine chemicals, that is pharmaceutical industries. Yeah, agricultural, pesticides, we can say it will come agriculture. So we have insecticides, we can say insecticides, etc. Then another one is petroleum. Petroleum. By petroleum, we have another one is petrochemicals. Petrochemicals. These all are industries. Wherever a chemical process or any process happens, there is a high chances of some pollutants get. It can either enter water body or it can enter air or anything. So these are the classifications. So now we'll take constantly water body. So when you get a water, I don't know how many of you, I have experienced this one. Sometimes some aquaguard or some filtering person, sales representatives will come to your home and ask to check your water. So what they will check initially, they will ask you to give a glass of water in a glass. So what they will be checking first? Yeah. Uh, so actually, my experience also like that. So initially they will be taking a glass of water. They will be having a TDS, total dis or TDS meter. They will dip it. They will tell a value. Then they will say this value is the safe one. This beyond that it's dangerous. You need this one. So basically business strategies. So there are many factors. So preliminary. Can you mute once? Yeah, thank you. Yeah, there are preliminary factors which we can. Suppose someone is coming with a water. You are running a what do you say, pollution control or monitoring uh, industry or some consultancy. So someone is coming and they are asking, I think my water having. So here also sometimes what happens is some problems happens. We ask some water treatment research people to check the water. So what will be the first? How will be? We cannot say you wait for come after 1 month or something. I will tell you what is the problem. So they want some immediate response. So we have some preliminary screening criteria. What are they? First one, whenever getting a water sample, what will be checking? Yeah, first of all, we'll be checking what is the color. So second one, we'll be checking any odor. Is the odor, any odor or any smell is coming out of that one. What is the third one? Yeah, pH will come. We cannot check by visibly. We cannot say, right, without any by help of any external things. Either we need a pH paper or we need something like a pH probe in order to understand what is the pH, right? So without doing any external things, what we can do, one is color, one is odor. We can check whether it is. Oh, so many people are joining still. Sorry, turbidity. Then fourth one is taste. So these are the preliminary screening factors we can always check for before what you say we are even though without going any deep analysis we can say by seeing these things we can say this water looks have some problem. So when we are looking into it we can see color, odor, then taste. These are coming from something like dissolved solids. Then turbidity mostly will come from suspended solids, right? Solids. So from these two terms itself, we understood there are some more things we have to check uh, before making a conclusion about whether the water is drinkable or what. So when I maybe some of you have experienced it, when jaundice or some that kind of disease is spreading around your area, what the medical officer will come, what they will be checking in water, what. Yeah, contamination, but usually when this kind of situation comes, what they will be? Yes, they will be checking coliform bacteria. I don't know exact number, but there will be a limit for that. If it is beyond that limit, they will be saying it is coming from this water source. Like that, they will be testing. So from informal factors, we'll be going to formal factors. So what are the formal factors for water screening? First one is organic load. Organic load. What are the things involved in organic load? One is, I think all of you heard about it, biochemical oxygen demand or simply biologic oxygen demand. Next one is chemical oxygen demand. Then total organic carbon. These are the things involved in uh, organic load. So next one is what? Next one is we'll be seeing what is the total suspended solids. Third one is total dissolved solids. Then what else is there? Another one is pH. What is the normal pH value for drinking water was suggested by Pollution Control Board? No, mm, this is a simple question. I also know the answer for a long time. So I'm expecting. So too neutral is it's too neutral is also. Answer is the according to Central Pollution Control Board, what is drinkable is considered 6.5 to 8.5. Hmm. That's the message they will give. So, so far water screening parameters we have done. So two terms we have seen is BOD and COD. So we'll slightly go through what are this BOD and COD. So what is the unit of BOD and COD we have used to see? We used to see milligram per liter. Microgram. If it is microgram, it's good. Yeah, milligram per liter. It is also called ppm. Milligram per liter. It's also called ppm, parts per million. So suppose we have a organic molecule. So suppose I am giving Ca, Hb, Oc, Nd, then some other. I don't know whether it's a pure organic or it have a substitute. So what is biological oxygen demand? So how much the microbes or biological biodegradable pollutants in water, which is given by BOD. how much oxygen is used to wanted to convert this. Suppose I'm writing microbes, it will consume oxygen and convert it into CO2 plus H2O. Suppose ammonia and H3 plus Y, some other compound. This is given by biological oxygen demand. We know in water there can be non-biological like other chemicals which cannot be degraded by oxygen. So in order to find that, we use another term called COD, chemical oxygen demand. So whatever the chemicals coming from industry may not be biodegradable. So here what we do, Ca, Hb, OC, Nd, X some other compound, we'll be using strong reducing agents such as, suppose we have sulfuric acid, then Cr2O3, then we will reduce it to CO2 plus H2O plus some other product. So like that, it is general introduction. We'll be coming detail. What is BOD 5? What is BOD 3? Like that. We have different tests. So 5 days, 27 degrees centigrade. Some those kind of tests for measuring BOD. So basically, from how much amount of oxygen is utilized to reduce this things will be the formal parameters to find BOD and COD. So what is next? We have seen like water body. Now I'll just I think all of you have opened and seen this Central Pollution Control Board website, right? Have you all got a chance to go through it? Hello. Yeah. So during my MTech, this was a just the standards, and these all are were a course to understand how much is the uh, different standards and all. It was very theoretical and it was very difficult to remember at that time. So I'm not expecting you all to remember these numbers, but still some numbers like what is a what is the BOD limit? That is what is dissolved oxygen needed. That is higher than 5 milligram per liter. BOD should be less than 3 milligram per liter. Those kind of simple numbers, I wish it will be better for you. If you are taking this course, it will be useful for you to remember those kind of numbers. This is the site for pollution, Central Pollution Control Board. In US, we have US Environmental Protection Agency. Hmm. This is in US. In India, we have Central Pollution Control Board, CPCB it's called. So this is the website we use. In that, we can see a tab called standards. So we have air quality standards, water quality standards. So vehicle exhaust also we can see. So according to the engine power, like how many cc, like for 350 cc vehicle, for 150 cc vehicle, all are different standards are there. It's in terms of pollution, emission of emission, as well as it will be also depend upon the noise limit also. Noise is also a sort of pollution. So I'm just showing this, right? All of you just go through this. You'll get a PDF file for different standards. It will be keep on updating every year or after every changes. So next one will be air quality parameters. So when air quality parameter says, we will be seeing one terms called, what is that? Aerosol. Sorry, AERO, aerosol. So what is aerosol? How can you define aerosol? Anyone? Hmm. Dispersion is dispersion of solid liquid in air. Air, or we can say gas. It is called aerosol. So what are there in a atmosphere? We have one term called particulate matter, and second one we have gas and vapor. So sir is specifically asking what is the difference between gas and vapor. Anyone gone through it? What is the difference between gas and vapor? Hmm. No, like it can be compressible and incompressible, we can say. simply. So when you go for the thermodynamic diagrams, you can see there is a temperature called critical temperature. So if you go from solid to liquid, liquid to vapor, like that, if you say there is something called critical temperature, TC. So anything beyond critical temperature, it is called gas. Below that, it is called vapor. So there is moisture is there in the atmosphere. If you compress it, so in a gas, a vapor can become condensed by applying pressure as well as temperature, changing the temperature. But gas cannot be done like that. That's the difference between compressible and incompressible. So I strongly recommend you to go through most of your chemical engineering background, go to thermodynamics textbook. In the phase diagrams, we have clearly mentioned. I hope I will ask this question for next class. I am noting it down. What is phase diagram? Phases we have solid, liquid, gas. Three phases are there. Three phases. At triple point, these all three phases will coexist. Even mechanical students are studying this, I think. So, what is the difference between gas and vapor? It is clearly given in the textbook chapter. So, I think all of you will get some time. Like it will take hardly 20 minutes to read and understand. So, I'll ask this question. All of you just go through that and come back. So, we're coming back to the topic. When we are discussing about air quality parameters, what are the major pollutant gases we used to uh, see in atmosphere? What is that? Suppose we are, it's called NOx, SO2, ozone, then carbon monoxide. Carbon monoxide comes from incomplete combustion. Then we have particulate matter. Hmm. Yeah, that's different according to size. I'll come back to that. So these are the more chemicals. So in vehicles, what is the control measure we use to reduce the emission of these things? What is it called? Monoliths. Our silencer has. Uh, it's called monoliths. This is called monoliths. They will convert and incomplete combustion products to complete combustion product, and it will reduce the emission to the atmosphere. So as I told, everything, when a vehicle is coming to a place, it will go through certain quality tests so that the emission level is uh, below the limits prescribed by Pollution Control Board. So that's it. Then one important thing, last point I would like to mention, what sir discussed in week one is particulate matter. So what are the two uh, categories of PM? One is PM10, 2.5. Can any of you define what is PM10? No, no, no. You can say it's micron. So particles having a size less than 10 micrometer is called PM10. So particles having size less than 2.5 micrometer is called PM 2.5. So what is this 2.5? What is this? A particle can have any shape, right? It it's not sure we have a spherical particle. We can have a particle like this. We can have a particle like this. So how we will measure the diameter? Anyone? I think you all went through this, so it's just to refresh your memory. That's it. So I think when I'm going through this, you'll be remembering more and you'll be having doubts and all like that. So what is the diameter used to measure the diameter? It's called aerodynamic diameter. So how can we define aerodynamic diameter? Why it's called aerodynamic? I think the question is proposed in lecture also, but no one answered properly. So any of you know why we called it aerodynamic diameter? Yeah, actually, whatever getting emitted to the atmosphere, it's transferring through air. So it's called aerodynamic. It has settling velocities, all those factors are. So definition is, it is the diameter of an equivalent sphere particle of density 1 gram per centimeter cube that has the same stock settling velocity. Stock settling means it's in the laminar regime. So that's the definition of aerodynamic diameter. So initially, sir have given a nice picture and all what why uh, PM 2.5 is more lethal than PM 10 and all. So I think those portions are clear to everyone. Fine. Yeah. So whoever coming from chemical engineering background maybe heard about there are three fluidization. Are you aware of the fluidization principle? Hello. Oh, I can't hear you. It's too much disturbance. Hello. Yeah, fluidization is something we come across fluid mechanics. Sorry, fluid mechanics. So it is a when we apply some what do you say when we suspend a solid under a gas or something. What happens is at a moment the solid particles will start behaving like a fluid. This process is called fluidization. So there are different regimes in that. While settling a particle, so when we the common term is called settling velocity. So settling velocity can be depending upon so many parameters. It can depend upon the density of the particle. It can depend upon the diameter of the particle. Exact equation I don't remember. So in Stokes flow region means the flow is predominantly laminar flow. So another is called transition regime. Third one is called Newtonian regime. So here, I think the settling velocity will be depending upon the exact equations for settling. I will give it in the next class. Settling velocity. In this case, settling velocity will be depending Stokes flow region. It will be depending on particle diameter square, whereas in Newton's law region, it will be depending upon dp raised to half. Like that, we have different settling regimes. So, if it is a Stokes law region, what will be the diameter of a spherical particle which having a diameter of 1 gram per centimeter square? According to that, this aerodynamic diameter has been calculated. So that's a simple way. If anyone, it's that by definition, it is nothing but it is the diameter of a equivalent spherical particle of density 1 gram per centimeter square that have the same settling velocity, stock settling velocity. So what I meant is, so you see, can you say what is the diameter of this particle? Hello? Can you exactly say what is the diameter of this particle? Anyone? We can't because these two lengths are different. So here also, if it is a center, this distance is different, this distance is different. So, but in order to calculate the settling velocity and all, we have standard equations. So there are other methods to find diameter also. Someone from chemical background, if they come across a particle technology course, particle technology, they have may heard about Martin diameter. I not going deep into that Martin dia, then ferret diameter, then something we will take as equivalent diameter, equivalent diameter. So something like that because we cannot assume all the particles are perfectly spherical, but all the calculations and equations we have is for spherical particles. So in order to what you say account for this, we'll be having something called equivalent diameter. So that's very brief. It is out of this subject, so you don't need to think much about it. So what we need to do is we have particular matter which is standardly classified into PM10 and PM2.5. This 2.5 is and 10 is in micrometer. So it is defined based on the aerodynamic diameter of the particle. So that's what will be coming more to this topic in light scattering. I'm not aware about that. Light, yeah, yeah, light scattering method might be. It's like like it's a colloidal particle. So what's the size coming in? It's in the colloidal range. So we have colloidal system. Have you heard about Tyndall effect and all? Have you heard of Tyndall effect? So when we pass light through it, actually what happens is whatever particle here, it's always in zigzag motion. Like the particle here will move here, it will come back. Like that, it is moving, right? I'm not this light scattering method. I will explain in next class exactly. But light scattering method, it usually colloidal particle will be always moving in the hello. Okay, okay. Colloidal particles will be moving in zigzag motion. Hmm? So when a light pass through it, its path become visible. That is called Tyndall effect. So it may be I from the name I presume it will be something related to this Tyndall effect. So I will get back to this question in the next class. The method and exact thing. Is it fine? So do remind me. I already noted it down. What is? I'll write it down also in my notebook. What is what is light scattering method? What is hmm. Okay. For PM 2.5. Okay, I'll elaborate it in next class. Fine. This is the I think this content covered for week one. So you have any other questions? I'll try to answer. More than that, if anything beyond my limitation, I will go to the professor or I'll search myself and discuss in the next class. So any doubts or anything? So I think first week is fairly straightforward and easy, right? So just defining things, what we are going to see. There will be calculations on BOD, COD, all those things will be coming in the next weeks. So okay. So slowly now, do you people want 10-minute break or anything? Or shall we go to the assignment questions and go through it slightly and finish the class? Yeah. What's the time duration told for this class? 2 hour, right? Yes, fine. I think we'll finish before that. So, can any of you, all of you, gone through this assignment or still pending about the answers? Okay, we will go through the questions and answers. So, first question is in the scheme of pollutants and environmental quality, which of the following sequence is most appropriate example related to path of any pollutants? So, path we have seen what is that? Initially, we have a source. From source, it will enter environment. From environment, it will reach receptor. This is the general pathway. So, first one is what? First one, we can say it's not right. Why? Initially itself human is given. So arrows are not coming. Sorry about it. It's arrows. So next one is vegetable soil pesticide application. Is it right? So what will be the answer? Then third one also starting with human itself. So it's also wrong. So uh, we have waste burning waste burning, then particle it's dispersing into the atmosphere when it is inhaled by humans. So answer will be D. Then what is the second question? Which of the following is not true about the pathway of pollutants in the environment? First option is mm, 1 second, sorry. The first option is the keyword fate and transfer apply to the behavior of pollutants in the environmental compartment. Is it right? Is it right? What is fate and transport? Anyone? What is fate and transport? Yeah, we have a source. I'm drawing again environment, then it will reach the receptor. So fate and transport is just saying about how it is transmitted. It is not telling what is the behavior of the pollutant in the atmosphere or anything. So this is which is not true. Okay, sorry. Sorry about it. So fate and transport is the behavior of pollutants in the atmosphere. That is right. So answer the read the question carefully. I have to. Which of the following is not true? So second, what is the second option? It is correct. What is the second option? The keyword source applies to mechanism of release of pollutants from a process or device. Is it right? It is right. Then, then third one is the source. Keyword source applies to the location where the human receives the pollutants. Is it right? It is wrong. So what is it called? It's called exposure. It is not source. It is called exposure. The interface exposure. So sorry. It is called exposure. Exposure. Mm. So the interface between the environment and humans is called exposure. Then for what is the fourth one? The sequence of pollutant pathway generally in environment is from source, fate and transport and exposure. It's right. So answer of this question will be C. What is the third question? In the scheme of a pollutant pathway, which of the following is an example of emission control? So third question. Emission control. We have to emphasize it is emission control. So what are the options? First one is catalytic converter in cars. So everyone already answered. A will be the answer. What is the fourth question? In the scheme of pollutant pathway, which of the following is an example of exposure control? Exposure control. What are the uh, options? Effluent treatment plant, remediation of contaminant sediment, then water filtration for safe drinking water, then catalytic converter. This option we can directly cut it because it's already at the emission level. The answer is water filtration. So we have to control exposure. It's already polluted from source. That is, it's already mixed with the things. So now we have exposure control. For that, we will filter the water. It's the usual way we employ at home. So fifth question is what dose response curve represent? Is it freight and transport of a substance? No. Is it exposure of a substance? No. Then what is the third option? Third option is toxicology of a substance. This is the right answer. So answer is C. Here also I think C, right? What we discussed? C. Yeah. So dose response curve we have already seen. We'll give a known dose. We will analyze the response like a tracer experiment. So it will have like linear, it can be have a threshold and go like this. It can have a non-linear behavior, etc. So what is the next question? Sixth question. Which of the following is true about LD50? LD50. What is that? Mm, A mass of it is a maximum acceptable limit of chemical in water. It is wrong about LD50. What is the second option? Like concentration, actually, I don't know from someone, the disturbance is coming too much. Yeah, it's fine. A concentration of chemical in water or air that will kill 50% of the population. Is it right? No. Uh, then option C is a mass of chemical that will kill 50% of population. That is the definition of LD 50. Then it is the minimum acceptable limit of chemical in water. That is also wrong. So option will be again C. Then next question. This is a little, when you look at once in the, hello, Sagar, can you mute once? Background sound is coming to little high. Yeah. In the case of groundwater environmental compartment, different zones can exist. Identify zone A and B that shows in the scheme below. Delta notes the water table. So we have air, soil, groundwater, and bedrock. So what is A? What is B? That is a question. Is it what is saturated zone? Saturated zone means filled with water. Filled with water. So A is not saturated zone. So that option is already eliminated. So A is saturated zone. B is Van der zone. Van der zone is nothing but it is unsaturated zone. So A is unsaturated, B is saturated. So it is also wrong. Sorry. A is unsaturated. It is right. B is saturated zone. So option will be seven. Option will be C. B is Van der zone is same as unsaturated, but again B is saturated zone. So option D is wrong. So option answer will be C. So can any of you unmute and read the question? I am getting little tired. So what is the eighth question? Can one of you, can I call by name? Is it okay? Yeah, Amjad, can you read the eighth question? So what are the options? Hmm. B. Is it? Can you go through the answers? Hmm. Third one. So where we will see the sediments? We have air here. We have water body. At the bottom, we will have sediments, right? So is it filled with air? Completely filled with air? It's wrong, right? So is there any chances of filled with air? So air options, we can cut it down. So now we have two options. All the pore spaces of the soil are partially filled with water or completely filled with water. What can be the answer? Is it? Is it? So it is at the bottom of water body. So it is below the, it's a saturated zone. So in this one, all the pore in sediments, all the pore will be, it's like a clay, you know, right? How when we see some small like waterways in that, below there will be dirt. So it will be filled all with water. It will be very watery, right? So all the pore spaces will be completely filled with water. That will be the option A. It's case of sediments. That's why sir has given a clear picture. We have air, water. Below that we have sediments. Is it fine? Okay. Sagar, can you read the ninth question? Hmm, 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 Hmm. What will be the answer? Yes, suspended material. It's a suspended material because turbidity is the only one we have suspended material. All other screening parameters, odor, color, taste, all this we have dissolved solids. So suspended materials in water is the characteristics for turbidity. So one second. Can we go to next question? Question number 10. Can I call Chandra Mohan? Hmm. Hmm. Is it true? So it's wrong. Second option, it is also wrong. Then third question, is it's wrong. BOD is microbes, COD is chemical. We have to add a reducing agent to measure chemical oxygen demand. What is the fourth option? Then what is the last option? Constituents. What about E? COD analysis include all the organic constituents that can be chemically oxidized using a strong, hmm, so yeah, chemically oxidizing agent. What the problem with D? Biological BOD analysis is indicative of biodegradable organic waste in water. So this is little tricky. It is which one is true? Hmm. It's biochemical. So it's includes biodegradable as well as so the answer to my observation is COD analysis of organic content that can be chemically oxidized using a strong chemical oxidizing agent. E looks more appropriate to me rather than D. So I'll get back to this question. I'm little having confusion, but according to me, E will be the answer. Is it fine? Yes. Hmm. This actually this both looks true to me. Uh, I will get back to both. And one can be the answer, but this both looks correct to me. So I'll get back to you with proper definition of BOD, biodegradable organic waste. So it's not only organic. Okay, let's see. Uh, this question I'll put into repository. Question 10. Question 10. Check. Hmm. Then what is question 11? Yeah. So it's look like both are correct, but let me check once. For looks like E is more appropriate answer than C, because organic and inorganic things will come, right. Not only organic, I think so, but I'll clarify this and come back to you. Then moving to question number 11. Can I call Abhishek? Abhishek, are you online? So can you read question number 11? Hmm, hmm. What is the answer? Anyone? So I think you all submitted the assignment, right? So op answer is D actually. You just go to cpcb.nic.in, go to that standards, go to water quality criteria. So I'm adding one more assignment. So dissolved oxygen, what will be the limit given by CPCB? Okay, find out what is the minimum dissolved oxygen that's required in drinking water. So find out this also. For BOD, it is prescribed by CPCB is less than or equal to 3 milligram per liter. Beyond that, we cannot discard or we cannot say it's drinkable water. So what is the next question? Question number 12. Oh, okay, sorry. You don't need to go. I put a screenshot also. This has been taken from Pollution Control Board site. So here it's also given. I have already asked, right, what is the pH for drinking water? Mm. So water organized outdoor bathing. Okay. It's also for drinking dissolved oxygen 5 milligram per liter, biological oxygen demand less than 3 milligram per liter or less. So next question, question number 12. Uh, can anyone of you can read? Surat Devan. Can you read 12th question? Or what about option D? Is it right or wrong? PDS means what we commonly take. So what is the answer? Can any of you? Yeah, A is wrong. We'll assume like it's wrong. B is a conductivity probe can be used to measure total dissolved solids in water samples where the concentration of organic can be neglected. We assume organics are soluble in water, then whatever suspended is inorganic solids. So B will be the right answer. So option will be B. Then what about question number 13? Match the following. Oh no. Mm, so the final one is BOD, right? D is BOD. So can anyone look and give the answer? Question number 13. So total suspended solids, what will be that? Total suspended solids will be giving turbidity. So then what is TOC? TOC will be giving organic load. Then TDS will be giving organic and inorganic load. So three. Then finally biological biodegradable organics. So it will be four. The option will be C. Then next question. Can one of you read? Nitish Singh, can you read for question number 14? Hello. Hmm. Is it hydrosol? It is the answer. It is aerosol. It's the definition of aerosol. Then question number 16. Yeah, right. Then next question. Can I call who is remaining? There are 14 people like Ebin Johnson. Are you available? or I will go for Sunjoy Kirdat. Are you online? Okay, I think some of them left already. So can any of you available, can you read the question number 15, which we already discussed? Option E is correct. Stocks. Hmm, Last option. Yeah. Not electrical mobility. Yeah. Question number 17. So what is question number 7? The term PM245 refers to the option A is the geometric diameter of particle which are less than 2.5 micrometer. Option B is the aerodynamic diameter of particle which are greater than 2.5 micrometer. Option C, the equivalent diameter of particle which is it is written. You have to be careful. That's why it is written equivalent diameter. But we just see what is aerodynamic diameter. So option will be D. So last question is which of the following is not a mechanism of particle deposition? What are the options? Brownian motion, which is a mechanism of particle deposition. Option B is interception. Option C is electrostatic interaction. Option D is mm, gravitational settling. Option D is aerodynamic drag. Then option F is inertial impaction. So answer is option E. Aerodynamic drag is not a particle deposition mechanism. So these are the. Is this the same assignment given for you people for this week? For week one? Okay, 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 okay. I am accessing from previous year assignments. So I'll be discussing previous year assignments so that you'll get more idea also. Like, so let me. This is assignment one. So everyone submitted assignment one. Okay. How many questions were there? How much? Only 10. Okay, okay. I think sir has 20. How many questions were there? Assignment one. 20 questions. Then fine. Okay, okay. If these are 18 questions, might be all easy, right? These questions, it's just a basics. So for this week, these are the contents I want to deliver. So there are two questions arised. First one is what is the scattering method for detecting particular method 2.5? That question I will get back to it. Then question two is in assignment we have question number 10 which have a little confusion. I'll be clarifying that also. Then what are the things I told you people to just go and find? That is what is the dissolved oxygen level in drinking water. Then one more thing I have told like these things settling regimes I have to discuss next time. Settling regime regimes the Stokes law region, Newton's law region. I will little elaborate. I won't go too much deep, but I will try to find give a insight to the topic. Then what else? What is a homework-like thing I have told to check and come right next class? Have anyone noted that? Yeah, that is phase diagrams like gas, liquid, solid, liquid, and gas. So, what is the basic difference between liquid and gas? Sorry, vapor and gas. Difference vapor and gas. So, uh, all of you just try to Google it. Don't need to go to textbook. You can Google it and see what's the difference between a gas and a vapor phase. So I will in the beginning of the class, I will be first covering what are the doubts asked in the class. I will clarify it. From that, we will discuss next week content, followed by this assignment, like some questions. So I think it will be useful for all of you, right? So we will go through like a discussion pattern, whatever. To my knowledge, I'll be explaining the class itself, and whatever I am doubtful, I'll be going back to the professor and or I'll go to the sources and get back to you in the next week. Is that fine? Yeah. Thanks for joining. Feel free to write to me if any doubts. I'll get back to you in a day or two. Okay. Thank you, everyone.